Hey, welcome back, students. We're going to continue on our discussion of translating chemical reactions into word equations. And so we're going to try to see if we can fit two examples in this video. And so we'll start off just with a very basic equation here, and we're going to go ahead and translate that, and then we'll move on to the second one. So let me put the first one up. Here we go. So in this equation here, we've got aluminum oxide on the left-hand side, and it seems like it's being broken up into two things. So when we look at this, we got to be careful not to make the mistake when we translate the arrow sign here and put yields. Okay, so we got to do a slightly different reaction here, because essentially what we've got going on is we have an AB type reaction going to form AB. And so if you think about this, what this type of reaction is this is a decomposition reaction. So the little yield sign has to reflect that this is a decomposition reaction. And so beginning the translation, I'll go ahead and begin over here with a 2Al2O3. This part right here, I've got 2 moles of aluminum oxide. And you have to make sure that you remember that aluminum is a transition metal, so we do need to make sure that we put in parentheses right here in the middle. And so I'm going to make room for that just so that we can actually get this done proper. Okay, so I'm going to put this here, parentheses, and then we're going to put in the numeral 3. And the reason we're going to put numeral 3 is because the charge of aluminum in this case is a positive 3. So we've got 2 moles of aluminum oxide decomposes, and notice that we use decompose because this is a decomposition reaction, decomposes to form 4 moles of aluminum and 3 moles of oxygen. Now here at the very end, be careful, this is oxygen with O2, so this means that this is oxygen gas. And so here is the example of how we take this chemical reaction at the top and translate that into a word equation. Each of the sections for coefficients are clearly identified as moles because each of those coefficients are mole numbers. And as we progress through, you again refine the skill of naming compounds and naming elements in the process. So let's move on to the next sample problem, and we'll finish up the video. So here's the second reaction that we've got. This is a balanced reaction, so you can assume that it is. If not, you can go ahead and stop the video, check to see if it's balanced, and you'll find out that it is. But okay, so here we go. Let's go ahead and begin this translation here. We'll begin with the first compound. Right over here on the left-hand side, we have 1 mole of this compound here. Notice the first element is a metal, so this is gonna follow the convention of a type 1 naming convention. So this is gonna be sodium. And then the complete negative part, which is sulfate. Okay. We'll move on to the positive sign. This is reacts with, and move on to the second compound, 1 mole of CaCl2. Ca is a type 2 metal, or excuse me, a group 2 metal, so it's going to follow a type 1 naming convention. So that's going to be calcium is just the name of the cation in this case, is just calcium. And the ion here is chlorine, but the ion form of this is chloride. Move on to the arrow. To produce. You could have also written yields, to create, to make. Those are all acceptable as well. And then we'll move over to the right side. 1 mole of calcium sulfate, and that's the plus sign, 2 moles of the last compound, which is sodium chloride. So there you go. This is the translation of this particular chemical reaction. In the next couple of videos, we're going to take a written equation, a word equation, and we're going to translate that into an actual chemical equation using the chemical symbols, coefficients, and subscripts.